Hi. Hello, thank you. I'm Diarmaid from the University of Manchester. So I think you might be slightly outnumbered here, Ben, but, you know, with the debate of where's better. But yeah, so I'm a lecturer here at the University of Manchester. Thank you, everyone, for coming to sunny Manchester. We've just heard from some of the updates from our clusters already. We're now going to move on to a bit more detail around some of the projects. So we have some great talks coming up. Unfortunately, Ian Walpole couldn't join us today, but that will help with catching up on time. So we're going to move quickly on to Edward Thomas from Viridor. He's a chartered mechanical engineer with over 30 years of experience in the process and power industry. And I'm going to hand over to him now and let him get on with his talk. Thank you very much.
Thanks, David. And just on the long-running Manchester or Sheffield debate, I live in Sheffield, so enough said, really. So thank you for having me. So I work for. Have you got the slides yet? I work for Viridor, and there we go. So I work for Viridor, and I'm responsible for delivering one of those first 8 Track 1 carbon capture projects at the Runcorn Energy Recovery Facility. And so I want to talk a little bit about some of the practicalities of trying to deliver that side of things and what it means for us as a whole. So first of all, a bit about Viridor, because we're a waste company, and I think it's important to understand the context of what we do and therefore why we're interested in carbon capture and storage. So we operate the largest fleet of energy recovery facilities in the UK, and the other kind of limb to what we do is we're involved in removing plastics and recovering plastics through both mechanical recycling and through a recent acquisition of Quantafuel, a plastic liquids organisation. So we're very much specialised in 2 areas of managing waste as far as that's concerned. And this is quite important because we've made a commitment as a company to become carbon neutral by 2040 and carbon negative by 2045, which is kind of tricky if you make most of your money by turning carbon into carbon dioxide. However, they took that decision, and again, it's important to understand where we sit in the ecosystem, in that everything that we're doing in terms of carbon capture and storage is funded by ourselves. We won't get paid any money by the government or anyone else unless we put tons of carbon dioxide into the HyNet infrastructure run by E&I. So it's been a big journey already to convince our shareholders, the people that perhaps your pensions are invested in or whatever, that actually they should be spending the money that they would otherwise take as profits to put into carbon capture and storage. So as part of this decision to move to net negative by 2045, there's a journey in terms of where we expect to be in terms of our approach to waste management. And obviously the first and the simplest element is reducing the direct emissions from the activities that we undertake, being more efficient in terms of that side of things. And investing in the recycling infrastructure. We built the largest polymers recovery facility in Europe, in Avonmouth, not so long ago. But the third step in that is for us to be able to start capturing the CO2. Frankly, we can't make this journey that we intend, despite those other good steps, unless we are capturing CO2. And whilst we have a large fleet of energy recovery facilities, the Runcorn facility is by far the best located in terms of pipeline and so on. And it's also our largest facility by quite a margin. And so it's a big bet, but we have to make sure that this one works before we're able to move on to those subsequent ones. And we do have plans for others in the Track 2 and indeed Track 1 extension. So what facility do we have at the moment? So we have a facility that processes roughly 1 million tonnes a year of waste, and a lot of it actually comes from Greater Manchester. It was built to service the needs of that wider community. There is spare capacity in terms of that side of things, which is used to try and run that facility 24 hours a day, 7 days a week, every day of the year as far as possible. And roughly 93% of the hours in the year, we are actually operating that facility. Most of that waste is actually brought to us by trains. So typically per year, we'll have 780 trains and about 40,000 trucks. Now, it's actually got 4 processing lines, and the first and the anchor element of the Greater Manchester contract was phase 1. And that's unusual both in the UK and in Europe, in that it has a large combined heat and power element. So it provides electricity, but process steam as well to our industrial neighbour, Ineos Innovin, to their salt works and their other chemical works, so quite an important part. And hence the electricity generation is much smaller, as you can see from the numbers there. We have the potential to produce up to 90 megawatts thermal of heat for those facilities. Another really important point in terms of what we do is that the waste that we receive is approximately 50% fossil fuel, 50% biogenic. So every ton of CO2 we capture, roughly half of that is something that can contribute to net negative emissions. We will be able to sell carbon credits, and that is very much part of the funding model that we would look to apply in terms of this facility. And so that's a really important part of the plan that we're wanting to develop. Another point that's worth drawing out is that Greater Manchester hopefully isn't going to go away, and the waste of the community isn't going to go away. And so although we are driving hard to increase the amount of recycling and the materials that are recovered from what would be a waste stream, all of the forecasts for the waste sector are that we have decades ahead, even with much improved recycling rates, of waste to treat. That's really important in terms of the underpinnings of what we do, in that our primary purpose is the hygienic treatment of people's waste. The CO2 emissions are a byproduct of that, and the electricity or heat that we generate from it, again, is secondary to that primary purpose of what we do. That's very important in terms of an investment decision for government, in terms of whether the waste sector should be playing a part in terms of carbon capture. We were actually quite a late comer to the industrial carbon capture scene, and in fact, our company tried quite hard to make sure that it was considered properly in terms of dealing with that side of things. But once the logic was understood that we weren't something that was going to come and go with the markets, we weren't dispatchable power that would respond to the energy scene, we were going to be producing CO2 regardless. And as far as possible, already 93% of the year, hopefully more than that, that we'll be producing CO2 at a very steady rate. So those combination of factors that are saying that we'll be producing the CO2 regardless at a steady rate, 50% of it's biogenic, so we can contribute to net negative performance, are all really important points. The other point I want to draw out about the facility itself is that we've actually been operating since 2014-15, and the part that we play in the community is important too. So not only does this give reassurance to government and other stakeholders within the carbon capture ecosystem that we're going to be there in the future. We're not a plant that's going to be built, we're a plant that has been built. But we're contributing to the community at the moment through skills, through training, through apprenticeships. And so far we've contributed across the whole facility more than £6 million to a community environmental fund. So it's an important part that we see ourselves as playing in terms of that just transition, that this isn't just about carbon capture, it's not just about our company, it's also the role that we play within that community. So in terms of the carbon capture proposal itself, we are very close to starting the front-end engineering and design for this facility, hopefully within a matter of weeks. And as I've said, the ratio of the tonnage of waste is approximately 1 million tonnes a year, and the ratio of carbon dioxide to waste is approximately 1 to 1. So 900,000 tonnes at least, possibly 1 million tonnes a year of CO2 captured through the process. So as was mentioned on the HyNet presentation, there's a spur pipeline that connects us to the core trunk of pipework that's been permitted by the development consent order that was talked out earlier, so around 9 kilometres of pipework to connect us to that side of things. I've already mentioned about the base load operations and about the biogenic content. That's such an important part of what we do. We intend to take our final investment decision in 2026, but it's important that that's at the same time as the spur pipeline FID as well, to make sure that that works as far as that's concerned. And we're targeting late 2028 in terms of the first capture of CO2, the first pipe to go down that pipeline in terms of that commissioning. These things don't come cheap, and we're talking about at least £500 million in terms of our company's investment to make that happen. So that's a combination of direct shareholder capital and loans from banks in terms of project financing. So we've carried out a lot of work to understand the feasibility of that, but also it's another level of reassurance we need to give to those stakeholders that this is definitely going to be a deliverable project as far as that was concerned. So in terms of the current status, we submitted our environmental permit application some time ago, but this was intended to be ahead of the FEED so that we could get the majority of the decisions confirmed on a generic solvent, so based on MEA, which I'll imagine is familiar to you all. But it also allowed us to drive out the thinking and confirm the Environment Agency's understanding of some of the other aspects that are peripheral to it, in terms of, for example, the cooling systems that we'll be using. And there's some interesting facets of that for us, in that because we'll be taking heat from what would otherwise have gone to a turbine, the cooling capacity that was required for the turbine is then freed up. So we'll be using a hybrid combination of reusing existing cooling capacity and dedicated cooling capacity as part of the heating and cooling cycle of that amine-based carbon capture. And also we'll be looking to blow down into a nearby watercourse in terms of the residues that are left after that process. As I said, we're expecting to start the feed in April, hopefully within a few months' time, and very much to be integrated within the infrastructure of our existing facility. So I'm pleased to say I'm actually running slightly ahead of time, so I'll try and wrap it up quite shortly. But I just want to sort of leave you with 3 main thoughts of what we're trying to do. We're trying to make sure that we're part of a just transition that is part of the community in which we operate, that continues to provide a service to the people of Greater Manchester and the wider in terms of that treatment of waste. That's the fundamental reason for being there, but we want to make sure that in the future we can do that in not only a carbon neutral but a carbon negative way. The fact that we are going to be there for the long term means that we're a thoroughly investable prospect, that we will be able to make sure we can commit to steadily filling the capacity that's created through ENI and the HyNet cluster to make sure that that transport and storage network is available. And because at least 50% of our waste is biogenic in content, and thinking back to the other element of our business model, hopefully we'll be taking more of the plastics out in the future. Hopefully that will mean that more of it is of biogenic content. Then our contribution to carbon credits and being able to remove that CO2 is a fundamental part of what we're planning to do. So thank you for your time, and I'll take questions at the end of the session.
Thank you very much, Edward. That was very insightful. So we're going to move now from a northwest perspective over to the Humber. We have two speakers here, so they get a little bit longer. So we've got Mayowa and Karina. They're both very experienced engineers with over 15 years of experience in project engineering on these sorts of CCS projects. I'm going to hand over, I believe, first to Karina, it looks like. Yeah, take the floor.
Thank you. Good afternoon, everyone. Thanks for having me. Today's presentation, I'm going to share a quick update on BPI's Humber Zero project, and then my colleague Mayowa will be sharing some of the key retrofit challenges of this project. Okay, let's start with BPI, who we are. So BPI is a power company, one of the power leading companies in the UK and Ireland. We have around 3.5 gigawatts installed capacity across 8 sites, and we have under construction additionally 624 megawatts. BPI is committed to invest over £2 billion to low carbon energy solutions, and we are around 206 employees across the 8 sites. Moving to BPI Immingham sites, where our project is based, BPI Immingham is a 1.2 gigawatt CHP plant located in the Humber region and is the largest plant of its kind in Europe and in the UK. And this plant has been in operation since 2004. Since then, the plant has undergone 2 different upgrades to improve the efficiency. One of the key features, we provide power and steel to the refineries, Humber Phillips 66 refinery and Lindsay oil refinery. And we also provide flexible and low-cost power to meet up to 5% of the UK electricity demand. Moving into our project, Humber Zero. So Humber Zero's mission is to deliver one of the UK's largest carbon capture projects in the UK. Our target is to capture around 3.8 million tons per annum together with Phillips 66. BPI's scope is to capture around 3.3 million tons, and this comprise the capture emission of 2 CCGT and 2 auxiliary boilers. The CO2 will be exported to the Viking CCS transport and storage network. And together with Phillips 66, we plan to invest in the initial phase around £2 billion. We are expected to create around 2,500 jobs between the construction phase and some permanent roles after operations. Now I will give you a quick summary of our journey. So we started this project in 2019 with the concept definition, and in 2021, the project was granted an ISCS funding by UKRI. Over this time, the project achieved different milestones. We completed in 2021 the pre-FEED studies with Wood. 2022 and 2023, we completed the FEED studies with Worley. And last year was a really important year in terms of development for the project, because we completed the FEED studies and we also completed the FEED verification with Bechtel. We also selected our carbon capture technology. We are working with Shell. In terms of planning and permitting, we submitted the application for the permit variation and the planning application last year, and we are expecting to be granted the permit and planning application this year. Looking ahead, our plans for 2024. So we are, at the moment, we are working in the selection of our EPC contractor. Our plan is to appoint the EPC contractor next month and work alongside the EPC contractor to further develop the project, basically get more cost certainty, schedule certainty, and work in our execution plan. Our plan And our aim is to get final investment decision in 2025 and get to commercial operations 2028. At the same time, we keep working with business and the selection and agreement of our business models. So all I can say that this is a very mature project, and we are looking forward to get to a final investment decision next year. Now hand over to Mayowa, who is going to provide some of the key challenges of this project. Thank you.
Thanks very much, Karina, and good afternoon, everyone. My name is Mayowa, and I hope we're going to get to FID next year. I think the track one clusters have done the heavy lifting, and hopefully we can, piggyback on that to speed things up to get to FID. Really interesting. We've talked about the policy side of things. We've talked about all of the complex commercial agreements and all of that. But I think we'd like to go into a little bit more detail around emitter projects. So my job is to kind of talk around some of the challenges that we've seen executing our project. And we do have a very interesting project, but also challenging. Challenging in the sense that the plant is already there. So we have a live plant that's operating today, producing power and steam. And so the box is kind of set in terms of some of the decisions that you like to make on a project, and you just have to work within what you've got. So that's a challenge in itself. And today I was going to share about 4 that I consider to be key challenges. I mean, everywhere you turn on the brownfield project, you're going to see challenges. Some of these ones are very specific to our site and to our plant. Others might be generic, okay? But I try as much as possible to focus on those that are specific to this plant so we can learn some lessons from there. And the first thing I would like to talk about is the ducting. Now, Karina said we are retrofitting carbon capture onto the back of 2 CCGT machines and 2 auxiliary boilers. And I'll try to put a box around those 4 emitters. Some projects you have one of these and it's big enough, but we've got 4 large emitters, and we have to find a way to collect the flue gas and send it over to the capture plant with 4 emitters. So the first thing that I'll talk about here is actually the ducting. How do you connect to an existing stack, and how do you do it safely and make sure that you're not impacting the existing operations of the plant? Now, this is really important. We want to capture CO2, but we don't want to disrupt our existing operations. This is where the money currently comes from, and so it's really important that we get this right. Now, one of the picture to the right, top right, kind of shows a little bit around the congestion that you see on the site. And the stack, one of the stacks is what you can see in the middle there, going into the big exhaust stack. And it's really congested, but we have to find a way to fit in 7 by 7 meter duct in between that little space and take it away 200 meters to get to the capture plant. And so because of that congestion and the fact that the infrastructure is there, the heat recovery steam generator on the back of which we have to tie in is already there. This has been designed for a specific purpose, and we need to bring in a new stack to it. So we had to do a lot of studies to assure ourselves that you can actually breach that stack, make a new connection about 30 meters up in the air, and send it through that little space to the other side of the road, or to the other side of the fence where the capture plant will be. Now, all of the study details are to look at, what we're doing to the pressure within the HRSG. Are we going to impact the efficiency of that? Are we going to impact the integrity of the HRSG? And can we actually suspend this stack up there? Can we walk around this congested area? And so all of that were detailed studies on their own. But the good thing is we can do it. But it does mean we had to pay a lot of attention and you had to bring in a lot of the experts to work on these specific aspects. After 2 years of doing detailed fit studies, we came to the conclusion that we can do it. And not only can we put in the new stack, we're not going to impact on the operations of the existing plant. Simply because the flow, the dynamics of the flow allows us to, transition from the existing stack and put in a new stack and just have enough pressure drop within the system to still allow the flue gas to move freely up to the point that it then goes into a booster, into a blower before it goes into the absorber, okay? So that's the first thing that kind of keeps us thinking, it got us scratching our heads, how are we going to do this? And so I felt it's important we talk about this challenge, okay? The second thing I was going to touch on is the fact that the plant currently operates in a very flexible way. I've heard the word dispatchable plant today. So this is very dispatchable. We can go from not producing anything to producing the maximum. And the figure at the bottom of the page there is trying to kind of show this in a way. And you can see the peaks and the troughs. And we've gone to the maximum, 1.2 gigawatt, and we can be at a minimum of 40 megawatt, or sometimes it even has to go offline. Now that's a very flexible power plant. And again, this has to remain so even after we've retrofitted a capture plant. Now that's a challenge. How do we bring a capture plant on the back of this? We have 4 emitters. We have to find a way to combine some of those flue gases. So not only are we can't, it doesn't make a lot of economic sense to have 4 capture plant trains. We don't even have the space to put all of the 4. And so the way to optimize the design was to combine flue gases. And so we combine, and we got to a solution that actually allows us to combine those flue gases however we want. Because currently commercial requirements cannot dictate which of the machines you put online. And so we don't want to put a capture plant on the back of it, and then we're constrained by how we can line up those machines. So currently we've had to implement quite a large number of dampers, very big ones, and you can see there, everything in color, red and green is showing whether it's closed or open, But basically the direction of flow is almost, like you can flow in any direction to any of the capture plant trains. Was a significant challenge, but again, we had to do a lot of modeling work. Some still, to be done in terms of the level of detail that you need to go to. Once you have selected the specific type of, dampers in this case, making sure that they can actually achieve the sort of operational requirements, because what needs to happen is that depending on how you want to operate the plant, you need to be able to switch, maybe open or close. So they need to be able to respond really quickly for this to happen. Well, in terms of a solution that works, this is how we currently set up. But it was a challenge, but in the end, we got a solution that works. So again, this is very specific to our plant, but those lessons should be applicable wherever you operate in this manner, right? So we don't have the luxury of building a new power plant and then making sure that all of the decisions are made by us. Some decisions have been made, we just have to work within those decisions. Okay. Some of you might be interested in this one. I heard it. Now, for those who have worked with Emin, you probably recognize NOx, and in particular NO2, and this could react with your Emin and to give you, sort of degradation products. So it does affect, let's say, the performance of the Emin process. Now, as a combustion plant, you will produce NOx. And NOx will have NO2 in it, which will then impact your Emin chemistry. And so every project, every carbon capture project should look at ways of managing NOx, reducing NOx. In our case, we need to find the best solution to kind of make sure where does the balance lie between having to install a new NOx control system or just finding a different way to achieve the same sort of objective, which is the plant is still working and performing, well. Okay, so if this were to be a new build, the NOx, in this case, a selective catalytic reduction system, would be within the boiler system, which is the HRSG. You kind of find a place in there where the temperature is right, and you can actually use that to bring down the level of NOx. Some plants do have them, where NOx emissions can be quite high. As I showed in the picture earlier, there's really no space. Even if we try to break this apart and put in a longer HRSG unit to have the SCR there, it's not going to happen because it's just not, there's no physical space to do this. So the only way to reduce NOx will be to do what we call the either end of pipe or tail end solution. So the flue gas has been produced, and on its way to the capture plant, you then have some kind of NOx control system there. And that's prohibitively expensive. Basically, it's impractical to try and do that because the cost of the project just balloons. Because you need additional equipment, you need additional energy. Suddenly, you're having to burn more gas, and that gives you additional CO2 that you then have to capture. So it just kind of spiral, in that way. Luckily, we decided to characterize the flue gas for our particular plant, and so we know exactly the NOx that's in there, and it's very low because the GTs themselves are, they have low NOx burners. And the auxiliary boilers as well, they really have low levels of NOx. And so because the NOx level is already low, we came to the conclusion that whereas for very high NOx systems or units, then it would make sense to try and do something to really bring it down. If you're in the hundreds, ppms, then you're looking at finding a solution that actually brings it down. Reduces by maybe 90% or something. But it's already very low. And so there are ways to focus more on the solvent itself to make sure you're selecting something that's more robust to the presence of NOx. That will give you a better way to manage your NOx. So in the end, we settled for not having to do anything to complicate, let's say, because there are drawbacks as well for having SCR, some of which are on that screen. Finally, the issues around constructability. This is not specific to our project, but we felt this is some of the things that all of the projects that we've spoken to are dealing with, and it has to do with all of the issues that you find on a brownfield, as well as issues that you find on new builds as well, right? So we are constrained in terms of the land that's available to us. So how do we build on this small piece of land? We have to look at solutions that includes finding off-site spaces where we can actually, put things down storage, car parks, and those sort of things, so we can, maximize the use of the space. There are issues around transportation. We are limited by width, how the modules can come to site. These challenges are not specific to our projects, but nevertheless, there are things that we have to deal with as we progress with the project. And so those are the 4 things that I wanted to share with us today. And thank you for listening.
Thank you very much to all our speakers. We do have about 5 minutes now for any questions, if anyone has any burning questions. We've got one at the back there, waving. Sorry, it's probably the furthest away point. Yeah, just there, standing up. If you could introduce yourself, please, and if it's for a particular speaker, please state that. Thank you.
My name is Kelvin. The question from Mayowa. You talked about the impact of the low NOx from your fuel stack system. Do you guys consider fuel switching in the future, like using fuel sources that are low emitting like hydrogen, and the impact of that increasing the NOx level you have on your flue gas?
Myra, are you okay to take that? There's also the Slido if anyone wants to put questions in there.
Okay, so once we have the capture plant, we retrofit the capture plant on this. There's no plan to change from that. So that becomes the solution to decarbonize this particular plant. However, we have 3 CCGTs on site. This project is looking at 2 of them currently, but there's a 3rd one, which is a potential candidate for fuel switching. And so as this space around hydrogen availability kind of develops, then we'll be looking to see what we can do with that machine. Yeah.
Do you have any other questions? I know John's got a question.
I guess for both projects, have you made any estimates of capture plant availability, planned and unplanned, over the first, say, 3 years?
Is that for everyone?
Yeah.
Maybe we can work down. Yeah.
Well, since we haven't started feed yet, any numbers that we've got are very theoretical. But from our experience of similar plants, roughly 95% availability is what we're targeting.
Yes, we have. We have undertaken a RAM study, reliability and availability modeling work. I think the answer to the question is not straightforward because we don't know what we're going to find in those early years. We do expect there will be some teething problems. We do expect we'll learn in those first few years. Whilst our model kind of looks at the stable operations, again, which kind of aligns with that 95%. But in the early years, we do expect, and that's considered in the financial model, that there will be some issues that we have to deal with. Hopefully, we'll be taking the experience from some of the other projects that have deployed outside of the UK and taking those lessons to kind of make sure that we minimize this sort of early life challenges as much as possible.
Thank you. We probably have a space for another couple of questions. Yeah, Stuart.
On the Runcorn plant, you're planning to gain an income from selling carbon credits, essentially, with guaranteed storage. How does the conversation with the UK government going on that? Because in a way, you're asking the UK government to underwrite the security for the long term, while you can take the money. I'm not saying that's a bad thing, it's just an extra issue that we have to think about.
Yes, just, I don't know how familiar you are with the sort of funding mechanisms that are being discussed, but the transport and storage systems are generally on a regulated asset base, whereas industrial carbon capture is on a contract for difference basis. So whilst the fundamental idea of that is that it does underwrite the CapEx and OpEx, but only per tonne delivered and with a lot of qualifications to that side of things. And therefore, there is an expectation, indeed an obligation, to recover monies from other streams where we can, and that will reduce the government's liability. So I think referring to the keynote speaker's comment about industry being relatively self-funding in the longer term, that is very much what the contract for difference model is all about. It's trying to make sure that there's a producer responsibility around this and also a market for those credits.
Brilliant. Do we have another question on this side? Yep, one over here.
Edward, because you're handling waste, which is so heterogeneous, does that mean that the gases that from combustion are also quite heterogeneous and non-uniform in composition? And do you have issues with NOx and so on, as Mayowa mentioned?
Good question, and it's something that that we've given a lot of thought to. So whilst we do deal with a heterogeneous fuel, and that's a real challenge for us, actually one of the benefits of size and scale that we're dealing with, and indeed the blending that we do when we receive the waste, means that we try and achieve a fairly consistent blend and burn in terms of what comes through. But nonetheless, both the biogenic content and indeed the calorific value and the CO2 content all are potential variables within that mix. So it is a challenge for us, and we do expect a degree of fluctuation in it. But actually, our experience of running about 11 plants, about 3 million tonnes a year, is that across the fleet, is that we feel fairly confident that we can get a consistent performance, and we'll be able to cope with those fluctuations as they come.
Brilliant. And unless there's any burning questions from the room, yeah, we'll do the Slido. Thank you. Yeah, so this one's for Edward. You probably can't quite see it. So you said that you'll gain revenue from the sale of biogenic carbon. How will the introduction of food collection affect this?
Well, first of all, the idea is that the government expects us to market carbon credits from the evidence of captured carbon, and the majority of that revenue goes to government. So that's the simple answer to that one. In terms of do we expect food waste to change, I think referring to the wider point, there are facilities that operate within existing food waste collection areas, and those that don't. I don't think we see a huge amount of difference in terms of biogenic content regardless in those different areas. And also our experience, and as you can probably tell from my grey hair, I've been in the sector for quite a while, and every year there's talk about the composition of waste suddenly going to dramatically change and our business model is going to fall apart, and it certainly hasn't yet. And the forecasts are that, and what tends to happen is that improvements in recycling and the composition of waste, and indeed the people that produce the waste in the first place using different materials, actually tends to balance itself out to a degree. And so whilst we might expect some changes, the removal of both carbon, fossil fuel content such as plastics, and the removal of biogenic content, I don't think we'll see a great change, but whatever it is, we're there with a system that's ready to treat it and capable of treating it, as we've found over the decades we've operated these plants.
Right, thank you very much. Before I hand back to John, could everyone please thank our speakers again?